for our simplifying radicals. Okay. It's easier if you know your perfect squares. Say 1 to 13. Perfect cubes. 1 to 6. Perfect fourths and fifths. 2 and 3. Now, you have most of those already memorized. If you ever forget, you have a calculator. No one's going to take your calculator away. But the better that you know them, the easier it makes things to just kind of remember. So, like your perfect squares, 1 to 13 would be 1 squared, 2 squared, 3 squared, 4 squared. So perfect squares would be 1, 4, 9, 16, 25, 36, so on down the line. They're ones that you generally know. We forget some every now and then, but most of them we know. Okay, we're familiar enough with. Perfect cubes. 1 cube's 1, 2 cubes 8, 3 cubes 27, 4 cubes 64, 5 cubes 125, 6 cubes 216. And you're not going to be as familiar with those, but you've seen a perfect cube before. Probably the last time you dealt with it was factoring a sum and difference of cubes. So we've seen them. No, we're better. We are better, definitely better with squares than we are cubes, but we've seen them. 2s and 4s, or 2s and 3s. 2 to the 4th is 16. 2 to the 5th is 32. 3 to the 4th is 81. 3 to the 5th is 243. And the reason I'm just saying those, they're the more common ones. Okay? It's not that you're not going to have to know, or not going to have to at some point use 9 cubed or 9 to the 5th, but it's not very common. So the more common ones you know, the better. And this is going to be your most familiar list up through there. Okay? So 9 squared is 81, 10 squared is 100, different ones like that. We feel pretty good about that. This is where they're going to help us. When we're simplifying radicals, the better I know what I'm working with or about the numbers, the easier the radicals become. So if I want to simplify something, if I'm asked to find the square root of 49, well, that's 7. The more I know my perfect squares, if I remember 7 squared is 49, then the square root of 49 is 7. That's what I meant. The more you know those, the easier it gets. Okay? Well, if I did some others up here, square root of 25 is 5, square root. And if we throw some things in here that look a little different, it's not going to make it any harder. If I saw a negative out here, my focus is the square root of 36. Square root of 36 is 6, so it's just negative 6. It's that negative sitting out there. If I threw a number, let's go 2 square root of 64. This would read 2 times square root of 64. So my focus is still at 64. Root 64 is 8. So 2 times 8, 16. So the better I know kind of these guys, I don't want to say it's easier, but it becomes easier. Then even if I get something like a fraction, let's do like 9 over 49. Let's do square root 9 over 49. Put it in a fractional form. Well, that just means I'm square rooting the top and square rooting the bottom. So 3 over 7. I'm not even going to let the fraction bother me. I'm familiar with some of the numbers. If I threw, say, a negative 5 out in front, so let's go negative 5 Square root 16 over 25. That's negative 5 times, so my focus is still this radical. So if I kind of pretend that's not there, I'm going to square root the 16, and that's 4. Square root of 25 is 5. And now I can multiply that piece. 5s would cancel, so I guess just negative 4. Or you can do negative 20 over 5. That would give me negative 4. Okay there? Cube root, similar. The cube root, we'll see the little cube up inside the radical, right inside the little check mark. So if I did like the cube root of 27, that's 3. So it's saying what number cubed gives me 27, that's 3. So again, the more familiar I am with these numbers, the easier it gets, okay? But we're going to forget some from time to time. You got your calculators, you can check things like that. If I did the cube root of 8, that's 2. I can even put a fraction in here. Cube root of 27 over 64. So that means we're doing the cube root of 27, which is 3, and the cube root of 64 is 4. So even the fraction's not going to bother me. I can work the top, I can work the bottom. Those pieces there. Okay there? All right, here's where we run into a little bit of trouble. When it's not one of those perfect ones, but that knowledge of the perfect ones are still going to help. So, if I want the square root of 75, well, 75 is not a perfect square. For the most part, I should recognize that pretty quick. I know that's not a perfect square. So then I want to think, what's a perfect square that goes into 75? And that would be 25. 25 times 3. And I'm thinking perfect squares because those are the ones I can do. So the square root of 25 is 5. And the 3 is not a perfect square, so it stays in. 5 comes out, 3 stays in. So I'm not thinking of just what number goes into 75. For example, if I did 50, square root of 50. I know 5 goes into 50. I know 2 goes into 50. I know 10 goes into 50, but none of those are helping me because they're not perfect squares. I'm thinking of a perfect square. I'm thinking of these guys, 4, 9, 16, 25, 36, 49, 64, 81, 100, so on. So which one of those? Well, 25 does. 25 times 2. Because these are the guys that are going to help me. The square root of 25 is 5. 2 stays in. Let's do like square root of, let's go 32. So when I'm thinking about a perfect square that goes into 32, I want the largest perfect square. Like 4 goes into 32, 4 times 8, but so does 16. I would rather have that largest. It's 16 times 2. Square root of 16 is 4, and leaves my root 2. So my focus is just what is one of those largest numbers that goes in there. Okay. So I had something like this. Let's go square root of 98. Now 98, not a common number we deal with, but you should know right away it's not a perfect square. Right? That part I know. So then I'm thinking down this list. And this one's a tough one because it's not very common. Just to kind of give you an idea, this is where your calculator can help you. You can get on your calculator and do 98 divided by 4, 98 divided by 9, by 16, and find which one of those goes into it. In this case, it happens to be 49. But that's just an idea of where your calculator can help you. You can figure out which one's going to go in there. So square root of 49 is 7. And then that 2 stays there. Okay there? All right. Okay. I'll come back to numbers in a minute. Let's look at some variables. All let's see here. The square root of x squared is x. Square root of x cubed is x square root x. Square root x to the fourth is x squared. Square root x to the fifth, x squared squared x. And we can keep going, but I'm trying to get a relationship and a pattern here. I don't want to memorize everything. So when we take a square root of something, that means we're seeing how many pairs we have. So a nice, simple, easy example. The square root of 36 is 6. Why is it 6? Because there's two 6's in there. The square root of 49 is 7, because there's two 7's in there. Square root of 25 is 5, because there's two 5's in there. They're pairs. So when I look at this, square root's a pair. I'm saying, how many pairs do I have in here? I have one pair. How many pairs do I have in the cube? Well, I have one pair and one left over. How many pairs do I have if there was 4? Well, I got 2 pairs. How many pairs do you have if there was 5? Well, you have 2 pairs and then an extra one. Looking for pairs. Square root indicates a pair because it takes 2 of them to multiply. Now watch this. It means a pair. We're looking for pairs. Pairs are 2. 2 divided by 2, 1. 3 divided by 2, 1. 1 left over. 4 divided by 2, 2. 5 divided by 2, 2. 1 left over. So if I said, you know what? I want the square root of x to the 26th. Well, 26 divided by 2, 13. It's just x to the 13th. I want the square root of x to the 11th. Well, 2 goes into 11 5 times. 1 left over, so there's 5 pairs, x to the 5th. 1 left over. So I'm looking for those pairs. Looking okay so far? Okay. If we see another variable, let's look at something like this. Let's go x to the 6th, y to the 8th, z cubed. And if you get more than one letter, we just do them one at a time. So all I care about is the x. When I'm done with that, I'll deal with the y. When I'm done with that, I'll deal with the z. So pairs. 2 goes into 6 3 times. None left over. I had 3 pairs. The y's. 2 goes into 2 goes into 8 4 times. None left over. The z, 2 goes into 3 1 time, 1 left over. So I got 1 z stuck in. It looks worse when you get multiple letters, but we're just going right down the line one at a time. So let's go numbers and letters. Let's go 9, a to the 5th, b squared. Looks worse when we mix the numbers, and let me go one at a time. We'll do the number, then we'll do the a, then we'll do the b. So I'm looking at the 9. Square root of 9 is 3. The a, 2 goes into 5 twice, so 2 a's come out, and 1 is left inside. I have 1 left over. The b's, there's a pair of b's. 2 goes into 2 1 time, b comes out. Here's my answer.
Would you have to write it like that? Like writing, you put like the a square and like the square of a, like.
And then the b after?
Yeah. Like that.
Oh, yeah. That's correct. That's a good question. So I was like, hey, can we do this? Yes, you can. Nothing wrong with that whatsoever. The only downfall would be you want to make sure, nothing wrong with this, but you want to make sure that it doesn't look like this, because now it's wrong. Make sure that b doesn't slide under. Okay. Typically, we'll put the radical at the end because sometimes we'll have more than one. But I don't want you to think that that's wrong. That's right. Just make sure that B's outside there. Let's look at one where we have a few things left in. Let's go 20. X to the 7th. Y to the 5th. We'll go square root. So we go in order. Number, then X, then Y. And when I look at 20, 20 is not a perfect square. That's okay. This is where I'm thinking my list. What goes into 20? 4 does. Now remember in your mind, don't think of just anything that goes into 20. You're thinking of a perfect square that goes into 20. So 2 times 10 wouldn't help you here. I want that perfect square. So now there's a 2 coming out. Square root of 4 is 2. 5 sitting in. I go to my x's. I need a pair of x's. So 2 goes into 7 3 times. 3 come out. 1 stays in. I go to the y's. 2 goes into 5 twice. 2 come out. 1 stays in. Look okay? Let's do this. Let's go square root. And let's go 300 a squared b c to the 9th. Again, get 3 letters, larger number, looks bad, but we go one step at a time. Number, then A, then B, then C. 300. I'm looking for the largest perfect square that will go into 300. Not just any number, the largest perfect square. Well, that would be 100 because it's 100 times 3. Square root of 100 is 10. 3 inside. Now the A. 2 goes into 2 once, so an A comes out. No A inside. The B. I only have one B. I don't have a pair, so it's stuck inside. The C. 2 goes into 9 4 times. 1 left over. So 2 into 9 4. And my extra. And 9 total.
2 goes into 9.
4 times 2 times 4 is 8.
Oh, and then 1 left over.
1 left over. Right. This was that remainder. So 2 went in there. In other words, there's 4 pairs.
Okay.
So kind of think of it like if we had 9 people in the room and we said, hey, let's everybody pair up. Somebody's not going to have a partner.
For a minute, I just like listening to you and writing, and I was like, did you just say that 9 goes into 4? Or 4 goes into 9?
Okay, now let's look at these variables. So let's make sure we have this down. All right, if I had x to the 5th, squared x to the 5th, 2 goes in there twice, 1 left over. Does that look okay? And if we had more letters there, it wouldn't matter. We just do it one at a time. When we change from a square root to a cube root, now we're looking for groups of 3. Cube root, groups of 3. Square roots, groups of 2. So this guy right here, there really is technically an understood 2 up in there. We just don't write it. It's an understood 2. If it's a cube, you'll see it. Now we need groups of 3. Now just think about this logically. If we said, hey, we got 5 people in the class, everybody getting groups of 3. There'd only be one group of 3. You'd have 2 others left over that don't have a group, right? So think about it like this. 3 goes into 5 one time, 2 left over. So if I'm doing square roots, I'm dividing by 2 and finding pairs. Cube roots, I'm dividing by 3 because I'm looking for groups of 3. So let's add another letter. We got X and Y. We're not going to worry about it. We're going to take care of X. Finish that. I'll take care of Y. So I'm looking for groups of 3. So 3 will go into 11 3 times. X cubed. And I'd have 3 left over. Now the Y, 3 goes into 12 4 times. None left over. That look okay? Whatever's up in here, that's what you're dividing the exponent by, because that's how you're seeing how many groups. So let's make a change. I'll keep the same problem. X to the 11th, Y to the 12th, but let's go 4th root. I know square root's the most common, and that's what you're going to see the majority of the time, but we have to understand what the grouping means. If I want the 4th root, I'm looking for groups of 4. So I'm trying to think of, all right, how many times will 4 go into 11? Well, it'll go in there twice. And there'll be 3 left over. So I've still got that 4th root of x cubed in there. And then how many times will 4 go into 12? 3 times. None left over. Another piece.